All right, so here is 2.3 patterns and nonlinear functions. So again, we are looking for patterns. We always want to look the pattern on the x value and on a y value. We always want to see what's happening here on the x values and what is happening here. What is happening on the x value side and what is the pattern on the y value side. We always want to know both to make sure we can figure out if the pattern works every single time. But now we are going to look at patterns of nonlinear functions. And it will be mixed. Some of them will be linear, some of them will be not linear. We want to figure out what are these ones right here, nonlinear. So let's take a look at the examples. I am going to start right off the bat with a word problem because I want you to see this pattern thing. So it looks like a worker's wages, W, in dollars, is a function of the number of hours he worked. In life, you get paid by the number of hours you work. So your wages is going to depend on the number of hours you work. So I already can tell you that my dependent variable is my wages. Okay? If I don't come to work, trust me, they ain't going to send me a paycheck. And the independent variable is the hours. Okay? So if I only work 20 hours, 30 hours, 40 hours, my salary, my wages is going to depend on how many hours I work. So I like to actually have an idea of what I'm doing here. So we always put the dependent variable on the y-axis. It's something we learned in the previous units. So I'm going to put W up here for my wages. And my x-axis is right here and is hours. Okay, we got to label it correctly. We're not always talking about x, comma, y. We have to pay attention to other variables as well. So there you go. I got my nice graph. I understand the first sentence. What is depending on what? Here's my graph. And then it says, graph the function shown by the table below right here. Label the x-axis. I already did it. The wages, my salary. If you want to switch the word wages for salary, it's going to depend on my hours of work. Tell whether the function is linear or not linear. Okay, so if it is linear, the pattern is going to be constant. It's going to be the same for the y values, and the pattern on the x values also is going to continue being the same for all of the x values. And then they asked me to write an equation to show the relationship between wages and hours. I am going to rewrite this. I don't like it a horizontal table. It's just difficult for us to see. I'm going to rewrite it. My hours is my x-axis. So I'm going to put hours right here. And my wages, my salary, is my y. So I'm going to put it right here, the W. Okay? So it looks like if I work 2 hours, I get paid $20. I wish. If I worked 4 hours, I get paid $40. And if I work 6 hours, I get paid $60, 8 hours, $80, and 10 hours, $100. Okay, not bad. All right, so let's take a look at the pattern. It looks like from 20 to 40, 40 to 60, 60 to 80, and 80 to 100, we're adding 20 every single time. So let me add a positive 20. But it looks like from 2 to a 4, 4 to a 6, 6 to a 8, and 8 to a 10, we are adding 2 every single time. So add a 2. All right, so I'm going to divide the pattern of the y values divided by the pattern of the x values. The wages divided by the hours. So my wages is going to depend on the patterns here. So 20 divided by 2, my pattern on the left, on the right here, divided by this pattern on the hours, times the hours I work, plus I need to know what do I get paid if I work 0 hours. Well, if you work 2 hours, you get 20. If you work 0 hours, I'm 100% sure at any job you get paid 0 hours. Maybe if you're a politician, you get paid something for not working. But most people, if you work 0 hours, you get paid 0 money. Okay? So I'm going to add that 0 in the back. Let's simplify our division here of patterns. So my wages is going to equal 10, because 20 divided by 2 is 10, times the hour. Okay? So there we go. And I'm pretty sure I went and I found my initial amount. It is, if I worked 0 hours, I would get paid $0. I don't have to add 0 in the back. So my wages is $10 an hour. There we go. Let's go ahead and create a graph and double check, because I don't like to do things and say I'm done until I double check with my graph. At 2, let's pretend that each of this line over here represent 10, a value of 10. 10, 20, 30, 40, 50, 60, okay? So at 2, I get 20 right here. At 4, I get 40. So 20, 30, 40. And at 6, I'll get 80. So at 6, I'll get 60. 40, 50, 60. And of course, my grid is too small. But if I connect the dots, it is linear. I'm going to connect in a nice line pattern here. And I'm going to keep going, and there is my line. Okay? And I knew that if I worked 0 hours, I would get 0 money. There's no such a thing as negative hours, but I will continue with the pattern just for the number's sake here. And there we go. We have a graph. We know what depends on what, even though they didn't ask us that. It's a good habit to have. We labeled it correctly, hours and wages, and we have our graph, and we have our rule. Okay? So I'm pretty sure if I asked you on the test, how much money would you get if you worked 30 hours? So you could replace your H for hours for 30, and you would find out exactly how much you get paid. Now, that was linear. That was a nice linear function because the pattern on the right stayed the same for the wages. The pattern here on the left stayed the same for all the values of hours. Let's take a look at a different example. Let's take a look at number 2. Let's see number 2 here. Let's do number 2. So graph the function shown in the table and tell whether the function is linear or nonlinear. All right, let's graph it. Let's just look straight at the order pairs and let's graph it. That's all they're asking. Well, they're asking to write an equation, but first let's graph it. 0 for x, right in the middle, but -1, so right here. 1 for x, right here, but you need to go 0 up and down, so I don't go anywhere, I stay there. And then 2 for x, right here, but we're going to go up to 3. So 1, 2, 3, right there. And then 3 for x, move 1 over. You got to go all the way up to 8. So 3, 4, 5, 6, 7, 8. There you go. I don't know about you, but if I put a ruler on any of these dots, if I put a ruler here, this 2 looks like it's lined up, but then the other ones isn't. If I put a ruler here, this 2 is lined up, but the other one isn't. So if I put a ruler here, yeah. So this is definitely not linear. It looks like it curves a little bit here to connect the dots. There's some sort of a curve. It is definitely not linear. Not linear. Okay? So we know it's not linear, but let's make sure we know that. From -1 to get to a 0, I would have to add a 1. Okay? -1 plus a 1 gives me 0. But from 0 to a 3, what do I do to 0 to get to a 3? I would have to add a 3. From 3 to a 8, how do I get it from a 3 to a 8? I would have to add a 5. As you can see, there is not a pattern. Okay, there's not a pattern at all. It changes every single time. So it has a pattern on the x values. I'm adding 1, I'm adding 1, I'm adding 1. But there is not a pattern on here on the y values. It is not linear, no pattern, not linear. We can see from the graph as well. All right. One more. Let's go in the back here so I don't do all of them on the front page. I want to do a little bit different one. Here we go. Number 4. Number 4, they gave it to you not on the table. You are more than welcome to go ahead and do your little table. Students like it. Go for it. They're not telling if it's x or y's. Graph each set of ordered pairs. Label each axis. Create a table. There it is. Write a rule. So they're not telling if it's x and y's. I'm going to call it x and y's. So here's my x values. And here's our y values. Let's go ahead and create a table. 0 for, this is x, this is y. 0 and 0 for y. 1 for x, 1 for y. 2 for x, 4 for y. 3 for x, 9 for y. And 4 for x, 16 for y. If you want to know right off the bat if this is a linear function or not, let's search for a pattern. So what do I do to 0 to get a 1? I add a 1. What do I do to a 1 to get a 4? I add a 3. What do I do to a 4 to get a 9? I add a 5. What do I do to a 9 to get a 16? You would add a 7. So there we go. No pattern on the left here. No pattern. So guess what? No pattern, not linear. There is a pattern right here from 0 to 1, 1 to a 2, 2 to a 3, 3 to a 4. But I have no pattern over here. I cannot divide by this pattern on the x values. Not linear. And how you're going to show this to me on the test? You just show exactly what I'm showing over here. Myers, no pattern here, not linear. I can prove it to you on the table. Okay, so let's go ahead and graph 0 for x, which is smack in the middle, 0 for y, right there. 1 for x, move over 1 on the right, up 1, there we go. 2 on the x, move over 2, but go up to 4. 1, 2, 3, 4. Move over to a 3, there we go, but go up to a 9. 4, 5, 6, 7, 8, 9 is way up high. As you can see, again, we're making that funky little curve, and it looks to me, it looks exponential to me. Okay, you can even say that. You can go further and say, you know, Ms. Myers, this looks like an exponential function. Those are good knowledge to have in our minds all the time, knowing what a graph looks like. Okay, some people may argue and say, it looks like half of a parabola. Sure, I will take that as well. Okay, so it's just looking at the set of values, organizing it, looking for a pattern, graphing it carefully, and tell me, Ms. Myers, this is not linear, there is no pattern, looks like an exponential to me, and that is a very good thinking analysis of all these values in front of us, okay? And we're done for that. You can do exactly the same thing for the rest of the problems. So good luck with your homework. Come and ask me for help if you need it. Good luck.